Hello, welcome back to our series on advanced maintenance planning, scheduling, and work control. This is video number 12. As our practice, we start our video with one of the messenger of Allah, Muhammadin sallallahu alaihi wasallam, peace and blessing be upon him. This is hadith number 12. Ali ibn Hussein reported, the messenger of Allah, peace and blessing be upon him, said, leaving what does not concern the Muslim. بالعربي الحديث بيقول إن من حسن إسلام المرء تركه ما لا يعنيه. صدق رسول الله صلى الله عليه وسلم. Now back to our video series, This is video number 12. In this series, we come to the last station on our analysis, on our sequence of maintenance planning, scheduling, and work control. This is the phase number 6, which analysis and reporting. Analysis, whatever we have done in our previous stage, in our previous procedures. Now, after doing the planning, scheduling, execution, and history recording, many companies actually history record and document their activities and their efforts. However, they don't utilize this history recording and documentation in the proper way. They don't complete the process by doing analysis and reporting. Of course, we need this analysis and the reporting to take decision and to get feedback. How we can measure our effectiveness? We measure our effectiveness through indicators and KPI, key performance indicators. Of course, there are many indicators, and every company and every industry has its own interest, so every company will customize whatever indicators, whatever metrics they go into measure. But the major maintenance indicators may focus in our video on the productivity, cost, availability, reliability, mean time between failure, mean time to repair, and the many other indicators and metrics we will consider it in our video. Of course, every organization and every company and every process owners must decide and determine whatever more interested, whatever more related to their business, whatever and determine their own performance indicator and their own metrics. Just an example of common KPI and maintenance performance indicators, including the workforce productivity, cost, availability, reliability, and the mean time between failure and the mean time to repair. Regarding mean time between failure, MTTF, what is the meaning of mean time to failures? It is a measure of the equipment or item or asset in operating condition or in operating time. It is a measure of time the equipment is performing whatever required, whatever owners required the equipment to achieve. It is a time from when the item is put into service or put into operation till the time when it fails. So equipment will go through either two situations, either operation or down. Operation, fail, operation, fail. So mean time between failure is the measure of or the indicating of this operating time or the up time. We call it operating time or uptime or equipment available during that time to serve the requirement of operation and production. The other term is mean time to repair. Mean time to repair It is one phase of the status of the equipment. Whenever the equipment fail, it takes some time to repair, and that time may be different from one to the another fail. So if we take the average of this failure time, if we sum up all this downtime or repair time or failure time and give the average, that is what we mean by mean time to repair. Or it can be measured in different way by using the corrective maintenance time, whatever corrective maintenance time, whatever failure time, whatever repair time, and collect all these total corrective maintenance time or that total downtime and divide it by the number of how many number it failed during a certain period of time. Of course, this mean time to fail and the mean time to repair can be measured for a certain period of time. We can measure it monthly or quarterly or every 6 months or every 1 year. So based on how many times it failed during this period of estimation or period of analysis. Meantime, it includes both operating and the repair time. So the mean time to failure and the mean time to repair, consider the operating time for mean time to failure and consider the repair time for mean time to repair. Mean downtime. Mean downtime, it is another metrics. Some people use this term, mean downtime, and of course it can be different from mean time to repair. How it can be different? By distinguishing between mean time to repair, which just the repair time. During that downtime, the equipment takes certain amount of time to do the repair. However, the mean downtime, it is the total time to bring the equipment back into service. So during the mean downtime, we might do the repair within certain period of that mean downtime with certain time during that mean downtime. We might not doing the repair during the whole time. The equipment might wait for something, or it is down for waiting for a spare part or waiting to be providing the scheduling and the planning and the resources required. So mean downtime, it is a time covering the repair time and non-repair time. It includes the time for scheduling activities, waiting for a technician, waiting for resources to be available to do the repair. So this is idle time, or we call it non-range time, or resources or trade transportation item to the workshop or to from one location to another location, or getting the spare part, waiting for the spare part. So this is the total downtime. Of course, during this time, we're not doing a repair during the whole time. We're doing a repair whenever the resources and whenever the parts are available. Mathematically, how we can estimate that mean time to fail? By summing up the uptime, where the equipment is serving the production, where the equipment is doing operation and the production, divided by the number of downtime, how many times it was down. So that will give us the average time of uptime, or the average time to fail. When we give the average, it will be MTTF, mean time to fail. Mean time to repair is similar. If we sum up all the downtime, uptime in the first time plus downtime in the first time plus downtime in the second time plus downtime in the third time, and divided by the number of downtime, then we got the mean time to repair. So MTTF indicating a mean time to failure, and the MTTR indicating a mean time to repair. Mean time to failure represent how long the machine or the equipment is expected to run perfectly as per the owner or as per the user required before it is failed. So it is again an average uptime, and this term is widely used in industry in production scheduling to schedule the repair time and to determine whether the next batch can likely be produced without interruption. Because once we know the average time of up, so it means it gives us clue, it gives us a prediction how long the equipment as an average is expected to operate without any interruption or without any failure. What is the benefit of measuring the mean time to failure and the mean time to repair? Actually, there are many benefits. There is a big list of benefits. We will highlight these benefits one by one. It is used in estimating equipment reliability because reliability, as we mentioned before, is measured analytically by viable parameters alpha and beta. And as we mentioned before, when beta is equal 1, it means the equipment is in the middle state of life. I just remind you about that bus stop curve. You remember this bus stop curve? During this period of time, during the midlife, beta equal 1. When beta equal 1, which is a major time in the life of the equipment, in that case, reliability function of time will be E to the power minus T divided by eta, because beta here is equal 1. So eta here is in that case, eta is 1 over mean time to failure. So this is another one of the application of mean time to failure. If we know mean time between failure, the reciprocal of this will be the failure rate or failure rate percentage. Once we know the failure rate percentage, thanks to mean time between failure, then we simply estimate the number of assets which is expected to fail. I will take this out to. So the number of assets fail per unit time will be the number of equipment. Suppose we have 10 equipment. So if we multiply by the 10 equipment by the failure rate is the reciprocal of the mean time between failure. So in that case, again, mean time between failure help us to identify how many assets will be failed at certain period of time. It will estimate again the equipment availability, because equipment availability is simply equal to mean time between failure MTBF divided by the total time. Total time is the period of investigation, so which is normally equal the mean time between failure plus the mean time to repair. Another benefit of mean time between failure is we can use it to determine the maintenance interval, the periodicity of doing time-based maintenance. If we have a time-based maintenance and we do maintenance at certain interval, the equipment, for example, will start to decline its performance. Then we will do again maintenance, so we get the equipment performance back, and then again another period of using the equipment. Then we repair the equipment or maintain the equipment, and this is what is the expected pattern of equipment behavior. How frequent we we adjust our time-based maintenance, it is that we can adjust this periodicity by the MTBF. So we can use this as MTBF. So the fifth benefit of using MTBF can be used to determine the maintenance interval. If we following the pattern of equipment condition, the equipment start with high performance, then by time due to tear and wear, it lose its performance. When we come to the time of service and time of maintenance, we do maintenance at this time to improve the performance of the equipment. We raise the performance of the equipment to high level, then the equipment started to lose its performance again, and so on. So this is what we call the time pattern of the equipment performance. So how frequently we maintain the equipment, how frequently we do the service to the equipment or do maintenance to the equipment, that interval, what we call the periodicity of maintenance, can be adapted based on the MTBF, or we can use the MTBF to define our interval of doing service and doing maintenance. The next one is maintenance decision. Before we have certain application. In this application, I just remind you about this application when we have the failure rate, and we use this failure rate to decide what is the best time to do the maintenance, and we do some cost calculation, and based on this cost calculation, we decide what is the best time to do the maintenance. All this calculation was actually based on the failure rate. When we know the failure rate in the first year, and the failure rate in the second year, and the failure rate in the third year, we use this data to take that decision. So again, failure rate can be used, and again, failure rate is linked to mean time between failure. It is measured by the mean time between failure. So we can use this failure rate to take that decision. The decision, I just remind you that the decision was which is the best reactive maintenance or time-based maintenance, and if it is time-based maintenance, how much it costs and how frequently we do that time-based maintenance, and what material we required. We discussed this in previous videos. You can refer to these videos in the last videos we've been prepared. Again, MTTR by itself, it can be used to identify the significant cause of failure, because if we know the mean time to failure, the mean time to repair for certain asset, and the mean time to repair for another asset, and as a consequence of that time to repair as a cost-wise decision, if we multiply this mean time to repair by the downtime cost, so we get the consequence of failure. Then we can apply Pareto analysis to know which is the 20% of our equipment which consume 80% of our complaint, or consume 80% of our effort and our budget. So again, it is used to identify the significant cause of failure. By itself, MTBF is a KPI. The better to have higher MTBF, it means the equipment can serve production for a lengthy or in a large period of time. Maintainability, mean time to repair, again, is an indication of maintainability. What is the meaning of maintainability? Maintainability means the easiness and the quickly of doing maintenance. So if MTTR is short, it means the equipment can be maintained in a short time. It means the equipment maintainability is better. We supposed to estimate mean time between failure and the mean time to repair and the mean time to failure. By the way, mean time between failure is the summation of mean time to failure plus mean time to repair. It include both. It include both status or both phases of the equipment during the equipment life. Do we actually really calculate these values or these parameters in our company or in our plant? The answer is yes or no. Unfortunately, most of organization does not measure these parameters, and accordingly, they don't get this list of benefit of measuring these parameters. So how we can measure it? It is very simple to measure these parameters, and we just introduce the benefit of measuring these parameters, and the benefit is huge and efficient and beneficial benefits, and we can use this again for decision making and for feedback. So how we can measure it? It's very simple to measure the operating time or time to fail, and we get the average by using the clock wall measurement. We measure the time the equipment was in operation and how long it takes in operation, then how long it takes to after this. So assuming this is the elapsed time, and after that time the equipment was failed, then the equipment was repaired and operated. When it is repaired, it takes this amount of time. So how long it takes to repair, we record this time. Then after that, after this time, it is now again up time. So the up time, how long it takes. So when it is up, it takes this amount of time, which is the difference between that one and that one. It gives us this up time. Then after this time, it fail again, and the difference between this time represent how long it takes to repair. So this is the difference. So this is time to repair. Again, the equipment is repaired, and it lasts for up till to that time. Again, the difference is this amount, and this amount is the uptime. So we repeat this process, for example, during the whole year, assuming this is the record of our elapsed time within a year. So, of course, if we have a computer maintenance management system, and if we have a good documentation system and work order documentation, it is easily to capture all this detailed information. And if we sum up all this time, we get the total uptime, and if we sum up all this repair time, we get the total repair time. So once we know the total uptime and the total downtime, it is now easy to estimate the, and of course we know how many times it takes it fail. 1, 2, 3, 4, 5, 7 times. So if we divide this uptime by 7, it will give us the mean time to fail. And if we divided this total repair time by 7 again, it gives us the mean time to repair. And we can use this unscheduled downtime divided by the number of breakdown to get that mean time to repair. And again, once we know the mean time to failure and the mean time to repair, very straightforward, we can even estimate the availability of the equipment, which is very simple, by dividing the mean time to failure plus the total time. In that case, the availability will be this percentage, 96%. We can use again this between time to repair and utilizing the Pareto analysis or Pareto rules or 80-20% rule. What is this rule? That Pareto rule or Pareto chart can answer many important questions actually. One of the question is, what is the largest issue facing our team or our business? Again, that Pareto will answer one of the benefits we mentioned before. It will identify the significant cause of failure. We now going to apply Pareto to identify or to focus on that parameter, identify the significant cause of failure by using this tool. It is a good tool. So we're going to apply this tool now by knowing that 20% where we should concentrate our effort and improvement and analysis. What is the 20% of sources of failure, of course, causing 80% of risk or complaint or suffer we are facing within our equipment. Again, Pareto will answer the third question, where we should focus our effort, where we should focus our analysis and our investigation to eliminate that 20% of sources of causing of failure, which if we eliminate, we will able to remove or eliminate or avoid 80% of the risk we are facing. Now, how we can apply this rule? How we can apply this Pareto rule? First of all, we have to have a good documentation system. Once we have this documentation system, it enables us to identify for every failure what was the failure in the history. And every failure will have its own code, and every failure will be counted how many times it happens, and for every failure how long it takes to repair. So we can tabulate all this information in that table. This is the number of the failures we have. We can code our failure. It can take any code system or just take a numerical series number as we use here for simplicity. And for every failure code, suppose this is a valve leak, for example. So any valve leak could happen, we will take the code number 1. Assuming this is the crack. So any crack will take failure code number 2. Assuming this is high vibration, for example, will take number 3. Bearing failure number 4, for example, it will take failure code number 4, and so on. For every one of these failure, we will capture from our maintenance management system how many times this failure happen. It happens twice per year, for example, if we consider a period of 1 year for our investigation. So what is the consequence of failure? In our case, the consequence of failure is the MTTR. So here we consider MTTR is the time to repair, how long it takes to repair. So failure code number 1, it repeated twice per year, and every time as an average it took 4 hours to repair. Failure number 2, it repeated twice, and every once it takes required 15 hours to repair, and so on. So what is the risk? What is the risk out of this data? The risk is the multiplication of the probability of failure and the consequence of failure. Probability of failure is the number of failures, how many times it happens, and the consequence of failure is the downtime. For example, downtime for every one repair of the failure code number 1, it took 4 hours. So this is considered as the consequence of failure. So the risk will be the multiplication or the probability of failure and the consequence of failure. So the risk here will be 8. 8 actually, it means 8 downtime per year. 8 hours as a downtime per year. Number 2, it takes 90 hours. Number 3, 19 hours, and so on. What is the next step? Of course, as we see here from the risk, we will realize that some of this failure could has or created a high amount of risk. So what we do, we should sort this risk now. It seems that number 4 has the highest risk, so it should come first. Followed by number 6, which has again a high percentage or high value of or high amount of risk. So it comes next, and so on. So once we sort that one, once we sort the failure probability of failures, and again this is the risk of every failure, then the next step is to get the cumulative risk. Cumulative risk of failure 4 is the failure risk of 4. Cumulative risk of 4 and 6 is the summation of both. So if we sum these two, we'll get the accumulation. Accumulation of risk of 4 and 6 and 9, the first 3 failures, will be the summation of these 3. So that will be the summation, and so on. So this is accumulation risk. Then what will be the percentage of this accumulation risk as a total compared with the total? So we sum up all this cumulative risk, and we get the percentage. What will be the percentage of the cumulative risk? The number 4 contribute by 23% of our total complaint or our total risk. 4 and 6 contribute, both together contribute by 44.6% and so on. So this is how we can use Pareto. It is easier to represent this numerical data in a visual or in a graphic way. So this is how we represent it graphically. That linear pattern represents the accumulation, and that bar chart represents the individual risk for number 4, for number 6, and so on. So the accumulation will be something like that. What is that 80%? The 80%, assuming we have this is the 80% of cumulative risk. So how many one of these lists contribute by 80% of complaint we are facing? It seems that only these 3 failures, the first 3 failures, contribute by almost 80%. So that represents 20% of our source of failure, which contribute 80% of sources of complaint or risk or hazards we are facing. So this is one of the application of mean time to repair. We use it in this analysis. Back to our data, just to remind you, that is this mean time to repair. So we use the mean time to repair and how many times it happens to answer all this Pareto question. What is the largest issue facing our team or our business? Yes, now we can answer this question. The largest issue facing our team or our business is number 4 and 6 and 9, because these 3 will almost contribute by almost approaching 80%. Not necessary to be 80% exactly, but at least we know that these three failures almost contribute approaching 60%, or we can add another one to be almost approaching 80% or 78% or almost equivalent to 80%. So this is how to use this. So it answered this question. Pareto answering that question already answered this question. And again answered the second question, what the 20% sources of causing? Yes, these 4. Where we should focus our effort, of course, now we can decide where to focus our effort. It means that, for example, we should not focus our effort on this list of failure sources, because its contribution is very less. We should concentrate our investigation and our interest in only to handle this number of causes of failure. Once we eliminate these causes of failures, we will able to get rid of almost 80% of complaint or suffer we are facing. Back to our KPI, what other KPI we can use? Of course, there are many KPI we can use. For example, the machining conformance during many different type, during the year time or during a monthly basic. For every month we can plot the conformance of the monthly planned maintenance schedule. Planned maintenance schedule conformance means how percentage of our plan being performed, how percentage of the plan we able to achieve in every month. May, how percentage it was almost 82%. In June, approaching 98%. In July, again it is 90%, and so on. What is the best practice? What is the target? Our target is to achieve 95%. So this is our target, and that graph indicating actually at what months we achieve the target. And based on that, we can investigate. We can investigate why we achieve more than our target in June, for example. Why we investigate that to learn from. To learn why we able to achieve more than our target in June. And again, the very low achievement during September, for example, has also to be investigated to know. And again, in January, again, to know why this gap between what we achieved and what should be achieved. So this is another way of KPI. This is what we call planned maintenance scheduling compliance. The number of failures again can be used as a KPI. During every month, we record how many failures we have for one asset, for certain asset, or for certain terrain, or for certain equipment. During every month, we plot these values and we see the trend, and it seems that the trend is improving. The number of failure is improving, so this gives a good indication. The number of failure indication again give good indication of the perfection of our maintenance program. So unless we have a good documentation and the reporting system, we will not able to see the trend of improvement and to see how that number of failure decreasing over the time for the certain period of time. Again, as we mentioned before, the mean time between failure itself can be used as an indication. Mean time between failure. It seems here if we plot the mean time between failure for certain asset or for certain equipment, and we see the trend, it seems the trend is improving and it gives increasing over the same period of time. So this is a good indication and a good performance. Availability again can be similarly. Availability can be plotted monthly wise, and for certain point on the time for between August and September, we launch new strategy or new system or new rules, and based on these rules we realize that yes, there is started to have and contribute to certain improvement. So the availability started to be improved compared with what was before. And again, it tells us for certain months availability was very low, so this also has to be discussed. And at this time of improvement, yes, the availability started to be improved and to be increased. So it's clear from this plotting to see how the equipment availability was improved, and it was far off control before that improvement activity. Here we have certain improvement activity. It might we revised our system, or we improve, we launch new strategy or new system of control. Backlog again is one of the KPI. We should following that backlog, we should make sure that it is within control. What is the meaning of backlog? Backlog actually it has different things for different people. People might use different definition of the backlog. One of the most common definition is backlog is the list of all the work order or the work task that has been planned and approved and ready for being executed, and it will be later get done. Again, it is the work order that have been approved but not yet started, not yet executed. It will be executed very later on, very soon. It is sometimes measured in trade hours, but the most common is to be measured in weeks. The unit of backlog is better to be used in weeks, as we will see very soon. What is the physical meaning of backlog? Backlog, whenever we have value for the backlog ratio, the time of or weeks, it measures the weeks, the number of weeks. we required to complete the list of the work in our file or in our list. So backlog is a list of work orders which have been planned and ready for execution. All this work in the backlog with the resources that could be applied to this work. So all the requirement was estimated, how many resources required, all the plan already done and ready for execution. So backlog is a list of work order already planned and waiting for execution. Sometimes we include predictive maintenance within our backlog list. Sometimes some people are not including BM in the backlog, but it is better if we include the BM in our backlog. Another definition which is less common, some people use this definition. They use backlog to just indicating the work orders that have passed their required by date. For every work order, there is a due date. There is a required date for execution. So this definition, this second definition, using that backlog to indicate what is the backlog, the work order that has passing their required date or due date. But this is less common definition for the backlog. We prefer to use the most common definition, which is the first one. After calculating the backlog, we get the backlog ratio. There is a difference between backlog and the backlog ratio. Backlog means the list of work order, just the list. Backlog hours means the summation of hours within that list. Summation of estimation hour. For example, if the first work order required 2 hours, the second work order required 4 hours, the third work order required 6 hours, and so on. So this list of work orders is the backlog. If we sum up all these times, it means the backlog hours. So this summation will be the backlog hours. What is the backlog ratio? Backlog ratio, if we divided these hours by the available resources in a week, whatever available resources we have, man hour in a week, so that will give us the backlog percentage. What is the backlog percentage or backlog ratio? What should be? It should be from 2 to 4 weeks. This is the best practice. Not less than 2 and not more than 4. Ready to schedule backlog. Sometimes we use another term for backlog size. We use ready to schedule backlog 1 to 2 weeks. A ready to schedule backlog indicating that all the material for the work order are staged and available and staged and being provided for the task. So in that case, we use ready to schedule. In that case, the ready to schedule will be from 1 to 2 weeks. How planners dealing with the work that was not executed before its due date? Of course, based on the priority of every work order, every priority has its execution due date. So based on that due date, what if when the maintenance people not able to adhere to that due date for some work order? In that case, the planner and the scheduler need to monitor this type of work which been delayed, which should not be executed within their priority system, to ensure that they rescheduled. If for some reason they are bended or delayed, it has to be monitored to redate or reschedule these type of work orders. This job will often have to be pushed into the next planning period or the next week or the next chance to make sure that it will not be forgotten or it will be unexecuted for some reason. The list of this work order should be as small as practically as possible. So we have to minimize the number of work orders that been exceeding their due date or their priority requirements. That list will be the main body of the work that required planner's attention. Sometimes we use this, when we use another term to identify this type of work order. We use the outage backlog. Outage backlog means outage. Outage means a work order which been executed after their executed date. Yes, it is executed. Yes, it been done, but it is been done. It is being executed far from its due by date. Since the backlog is by itself is an indication, it should be within a certain limit. It should be, as we mentioned before, between 2 to 4. So we have to monitor the backlog ratio and make a trend of that value to see how it is a trend. Of course, the backlog will grow and or shrink. Grow when work order added to the list. Shrink whenever certain work order being executed. Once it is executed, it will be removed from the list, so the work or the backlog can grow or shrink. Grow as job added and shrink as job completed and executed. Sometime emergency or work that not been identified or not been planned initially with a written work request are not part of the backlog, because this is will be treated by the supervisor. He will take action about this emergency work, and there is no need to be within our backlog. As I mentioned before, backlog ratio is measured, which the value between 2 to 4 is measured by this simple expression, backlog hour. Backlog hour is a summation of work order hours. This is summation of work order hours in our backlog. What is the summation? We divided that summation by the workforce we have per week. Workforce means how many hours in a week. Say we are working 5 days, and every day we are working one shift 8 hours. So that will be the number of work in a week for every worker. So every worker will work 40 hours in a week. Multiply this by the number of workers. So suppose we have 10 workers, so that will be times 10. Suppose we have backlog hours in our backlog file. Suppose we have 1,000 hours. So if we divide 1,000 hours by this 400, it will give us the backlog ratio. That should be between 2 to 4. That ratio should be between 2 to 4. What if it is not within 2 to 4? What if it is less than 1? Or whatever if it is more than 4? If it is not within that range, it means efficiency of scheduling of the workforce is difficult. We will face difficulties in scheduling of our workforce. Difficulties in what way? If it is less than 2, it means we have overstuff. So we're not utilizing our workforce effectively. If it is more than 4, it means we have shortage of workforce. It means our workforce will not be sufficient to handle all the work requirement. If it is not within that range, it means no balance between available and required resources and the required work activities. The value of the backlog should be trended weekly or monthly, as we see here, to see what is the trend. What is the trend of the backlog ratio? Of course, as we mentioned before, it should be between 2 to 4. So this is a preferable range. It seems here that the trend is not within the required trend. What happened? Why this month has very low backlog ratio? Maybe back to our expression about the backlog. This expression will explain actually why this backlog ratio is low. If the backlog ratio is low means the backlog hours could be low, or the resources we have is high. So suppose we have the same workforce resources, so in that case the backlog hours will be less. That is what is indicated here. No enough scheduled work. It means our identification, our planning, and our scheduling is not creating enough work order. That's why the backlog hours, the backlog ratio will be low. The opposite situation happened here in this time. High priority work not getting done. Why? Because in that case, the backlog ratio will be very high. So if the backlog ratio is very high, it means we don't have sufficient resources. Our workforce is shortage. We have shortage in our resources. So since we have shortage in our resources, means there will be delay in work execution. That delay can affect even high priority work, and in that case, operations will not satisfied. They will complain. Why complain? Because of some of their high priority work will be delayed, will not be executed on time. So how we can handle a situation like this, how we can eliminate and how we can avoid this type of high priority of backlog ratio? Yes, there is some action has been done here, and the trend started to be reduced. So what action been done here to overcome this high value of backlog ratio? Actually, the action could be through overtime. And once we allow overtime, the backlog ratio, it means we provide extra resources. It reduces the backlog ratio. Or outsourcing, we can utilize third party or outsources contractor to supply additional workforce, and this workforce again will reduce this high backlog ratio. So as we see here, there is a fluctuation in the trend of our backlog ratio, and again we might ask why this fluctuation. How we can explain this fluctuation in our backlog ratio? Actually, to explain this fluctuation, it is better if we trend again our workforce, because workforce has a direct effect on the backlog ratio. Back to our estimation equation, backlog ratio is controlled actually by two parameters. The first parameter, or the work order which is created, and the resources. So the resources is again a main contributor to the backlog. So to explain that fluctuation in the backlog is better if we utilize again another trend for workforce distribution and trend. As we see here, yes, that workforce trend explain why this backlog is fluctuating. It seems that whenever we have high workforce is measured on that axis. If we have a high workforce, it reduces the backlog ratio. Whenever we have less workforce, the backlog ratio increased. So again, this is explaining that fluctuation in the backlog ratio. Numerically, how we can measure this backlog ratio? Let us take a very simple application to measure the backlog ratio. Suppose we have 100 maintenance workers, 100 employees in certain section or in certain maintenance area. They are working 5 hours, 8 hours per shift, and 5 days per week. So 5 times 8, it will be 40 hours per week. Assuming that we have a backlog, and that backlog including certain work orders, and when we sum all the estimated hour of these work orders in our backlog, it comes up 20,000 hours. So in that case, what will be the backlog ratio? Very simple. if we get the ratio between or divide this backlog hours divided by the number of workers times the work hour per week, so we get the backlog ratio. So this is very simple estimation how we can estimate the backlog. By the way, we can use this backlog ratio estimation for craft wise. Yani we can use it for static craft, you can use it for welder, we can use it for fitters, we can use it for machinist, we can use it for electrician, and so on. So it can again give us a clue and give us a wide picture about our resources distribution. The one craft which has a high backlog ratio, it means they are suffering less resources. And again, the craft which has a less work backlog ratio, it means they have overstuff. Another application, assuming we have different work orders in our backlog. This is a typical backlog, assuming this is the backlog we have. Our backlog has 27 work order, and every work order has its number and estimation hour. So if we sum up all this estimation hour, so this is the backlog hours. This is what we call the backlog hours. This is the backlog. This list is the backlog. And this summation of estimation hour is the backlog hours. And if we divide this backlog hours by the number of workers times how many hours per day times how many days per week, which will give us this amount. If we divide the backlog hours by the man hour available per week, we will get the backlog ratio. So backlog ratio is another KPI, so we can use it as a KPI. Again, unless we have this documentation system, unless we have a good work order system, and unless we have a good estimation of our work order, we will not able to use this data to get one of the KPI, which is the backlog ratio. Another KPI is the schedule compliance. Schedule compliance means how percentage of our schedule we able to complete. This is the schedule hours actually worked, how many hours we completed within our schedule or within our plan compared with what was the target, what was we expect. So this is the schedule compliance. What is the best practice compliance? It should be 90%. And of course, we cannot satisfy 100 schedule compliance. Why we cannot satisfy 100 schedule compliance? Because we expect some emergency or some delay or some difficulties we are facing. So of course, it is logic. It is not logic, is not practice to have 100 schedule compliance. Even if we have 100 schedule compliance, it will be questionable. So what if the indication if we have this schedule compliance comes as 100%? If it happens and if the emergency work and add-on are also performed, it means that estimation might be overstated. It means the planners estimate the work order estimation will be overstated. It means we don't have a proper estimation system, we have overestimated. So we have to, this is a benefit of having KPI. This is one of the benefit. We should take feedback from this result or from this indication and back to our planning estimation and revise our planning estimation. Of course, again, it's better if we can trend more than one parameter, because if we have a fluctuation in any one of parameter, the other parameter will explain. Of course, if we talk about compliance and the emergency, of course, whenever we have an emergency, it will displace whatever planning we have, whatever scheduling we have. That's why when emergency increase, compliance decrease. So compliance and emergency has inverse relationship. It is not proportional relationship. Inverse relationship means whenever we have high emergency, compliance reduced. Whenever we have less emergency, compliance increased. Why? Because emergency work will displace scheduling work. Emergency work will take place instead of scheduling work. How we measure schedule compliance? Schedule compliance means scheduled hour actually worked, as we mentioned before, divided by the total hours scheduled. Estimation accuracy. Estimation accuracy again is another important KPI. It indicates actually how efficient our planning estimation. It is the ratio between actual hour completed divided by the estimated hour. Estimated hour should fall within the range between 85% to 115%. It means we allow plus or minus 15% deviation between estimation and actual. How we got these figures, how we can get that estimation accuracy percentage? Simply, when we have a work order, the planner estimate how it is expected to complete that work order. Whenever that work order is executed and completed, as we mentioned before, part of the documentation is to document the actual hours it took. So if we know the estimated time and the actual time, we able to get the estimated accuracy. How we can use graphical or visual aids to control that estimation accuracy? That's what we have, what we call the scatter diagram. This is scatter diagram. It is a very interesting diagram where the x-axis indicating the estimated hours and the y-axis estimated plotting used for plotting the actual hour. So this is for estimated hour and this is for actual hour. Any mark in that graph is a work order. So this is one work order. This is another work order. So every mark here, every cross here is a work order. So we capture all the work order in our industry or in our company, every work order within certain period, within a year, for example, or within a month or whatever. And we ask ourselves for that work order, for example, how long it was estimated. It was estimated as per our planning to require 30 hours. Then how it took in reality, it took 18 hours, for example. So what it means? It means here it took less than estimated. So how we can use this as a KPI? It directly tells us that we have overestimation. How it could be? How it takes 18 hours while it was estimated 30 hours. So again, this is a typical example of overestimated. So we have to back to our planning and revise our estimation and adapt our estimation based on that feedback. On the other way, and on the other side, suppose we have another work order like this one. What was the estimation of that work order? The estimation was 20 hours. How long it takes? It takes 60 hours, 3 times. So it seems here there is something wrong. What could be the wrong here? What could be the wrong? The wrong could be either estimation, it could be underestimation, or it could be the actual hour being delayed for some reason. So we have to investigate why these specific work orders took 3 times the amount it was estimated. So it means there is something wrong here. Either it is underestimated. So again, we take feedback to the planning and adapt our estimation. Or maybe the estimation is realistic, however, the execution was delayed for some reason. So we have to investigate why. That could be maybe because of the delay in releasing the equipment, delay in isolation, delay on supply of material and spare part, delay from the outsourcing, or lack of experience of our crafts, or lack of supervision. Could be many reasons, and any one of these reasons has to be discussed. There is this shadow area actually this is area in the middle. This area actually, this is what we mean plus or minus 15%. And any value here, if we add plus 15%, and if we subtract 15%, so that will be the shadow area. We call it the best practice area. Whatever work order within this area, that will be okay, because it means it is satisfy the 15% allowance. Of course, even if we have an excellent planner or an excellent execution, we never expect that all the estimation will be the same as actual. That's why we allow as a variance of plus or minus 15%. Either the estimation will be more 15% than actual or less than 15%. That is accepted. So that is the accepted range. Any work order in that area means it took times more than estimation. Any work order within below that area, which is that group means it took actual time less than estimation. So this group, it means underestimation, directly underestimation. This group could be for two reasons. Could be either overestimation, or it could be improper execution or delay in execution or difficulties in execution. So again, that has to be also considered, has to be investigated. There is another one issue we have to discuss here actually. We'll realize something here actually. Go back to, we see something interested here and here and here. Many work orders being taking this actual hour, which is 24, and many work orders are here clustered at this time, which takes 16 hours. And again here within that 8 hours, what it indicate that many work orders was completed at the end of the first shift, and a big group of work orders, larger group of work orders being reported as completed in the end of the second shift, which is 16 hours. And again, as we see here, a very large amount of work orders being clustered here, concentrated here on the third shift, which is 24 hours. It gives indication what? It gives indication that the workers who complete their work order before the end of the shift, they delay the closing of the work order to the end of the shift. They pretending that it takes the whole shift time. That's why many work order was being reported, was being closed during the end of the shift time. So this again another issue has to be discussed. It is a work control issue. Once we realize some trend like this, it needs a work control. It needs to revise our coaching and our supervision. Let us take a practical application on that issue on the scatter diagram. How we launch how we can establish that scatter diagram. Let us back to our backlog. Suppose this is our backlog, and we able to capture the estimated time and the actual time for every work order. After, of course, after being completed, this is a work backlog after being executed. All the list of work order that being executed. How we can use this data? Of course, unless we have again a documentation system, unless we have a good documentation and the reporting system, we cannot get this information and we cannot get all this KPI and this feedback. So assuming we have a good documentation system and every work order, we can answer how is the actual time, how was the estimated time. Unless we have this time it will not help us actually to utilize this scatter diagram. So how we can use this data? Simply, we first establish the shadow area. This is whatever within that area will be considered as accepted, because this is what we call the diagonal line. The diagonal line is just the symmetrical line. Symmetrical lines means the estimation and the actual are the same. So for example, if this is 24, this is 24. So this is what we call the diagonal line. And if we add at any time, suppose this is at time estimation hour 10, suppose we add 15%. 15% means 15% out of 10, it means 1.5. So that will be 11.5. And 10 minus 1.5, it is 8.5. So once we get these 2 points, so we extend a line passing from the original to that point and extend that line. And again, starting from the 0 point to that point, we'll get that line. So any work order will be located, any work order here from that list will be located within that area. It will be accepted, it will be okay. Suppose one work order required estimation time, say 14 hours, and it takes 13 hours. So 14 and 13, this is 13, and this is 14. So that particular work order will be located here. That work order will be okay. Suppose another work order, it was estimated 18 hours, but it took only 10 hours. So how we locate that work order? It will be located here. That will be considered as, if it took less than time, if it takes actual time less than estimation time, it means that work order has underestimation. Again, another work order which was estimated at 20 hours as an estimation time, but it took, say, 30 hours. So that 30 hours actual, and that is 20 hours estimation. So it will be located at this position. So that work order has to be discussed, has to be investigated, why it takes very much longer than what was estimated. The reason could be, as we mentioned before, could be one of two reasons, either underestimation or improper work control or difficulties in execution. Again, that has to be discussed. Back to our data. So if we took this data and we proceed similarly in that way, we will get that scatter diagram like this. So that will be the case we represent. Let me discuss one issue. Assuming that we have a case let us just clear what we have done here to utilize this chart for one other issue. Assuming that we have a scatter diagram which comes like this. What do you think of that scatter diagram? If you get your information from your system, from your CMM system, and you plot all your work order and you come with a scatter diagram like this, what do you think of this diagram? What do you think? All work order are located within this diagonal line. It means what? It means all estimation is the same as all actual. It means all work order estimation equal actual. It never happened like that. Practically, actual. Logically, it did never happen like that. Even if you have an excellent planners and an excellent execution system and excellent work control system, it never happened like this. Because nobody is excellent in everything 100%. So it means what? If we have a system like this, it means we don't have an estimation. The planner wait the execution to tell him how long it takes, then he use the feedback and consider it as an estimation. That's why it could happen and it could come like this. I hope you never do that. Thank you and see you inshallah in the next video. Will be continue with you in the next video inshallah.